Welcome to this video, which is the second part of the Solex 26 FV carburettor rebuild, where the castings will be renovated. First things first, a good clean with engine degreaser. All these parts have been left covered in the degreaser for several days. Having wiped off the degreaser, the aesthetic appearance of the castings was unsatisfactory, with staining from the fuel. So they will be sandblasted. Depleted glass grit, not glass beads, will be used. It is not sand. This has been used several times and has broken down very fine, so it will give a better finish. This is being done outside of the cabinet as the material is very dusty and will block the filter too quickly. Grit blasting is the fastest way to remove these sort of deposits, but the stoppages are infuriating. This piece of scrap metal will protect the bearings. They're all cleaned and ready for inspection. These parts don't fit together perfectly, but more worrying than that, the throttle body to manifold flange is very distorted. This can be seen clearly as it rocks against the ground flat block. This shot gives a better idea of what has happened. The gasket is very thick and over-tightening the nuts crushes it at the ends, but not in the middle, so the flange is bent. This will also need to be addressed. The castings are matte from the sandblasting. Rubbing them with a brass brush will buff them up. This is one from a cheap set. A suede leather brush also works well. This technique works on many materials, alloy, brass, and gives a realistic, freshly die-cast finish. You can see the difference on the side that has been done. The finish obtained can vary slightly from part to part, so it's always interesting to see how it comes out. This top part has come up very well. A tiny brush is useful for corners. You just have to keep going until you have an even finish. Let's try an old technique for flattening the castings. It could be machined, but the shapes make them very difficult to hold. A piece of abrasive paper is put over a flat surface and the part rubbed against it. Attempting to rub the part in a random orbit to cut it as evenly as possible. You can see the low spot at the left where the sandpaper has not touched it. This piece rocks so badly that it's difficult to hold square. It may be possible to use this method, but it would need a lot of work. I will come back to it. This is still not a satisfactory fit. They're still rocking a bit. At this point I got bored and made this pop-pop boat engine instead. It's made from some copper brake pipe and some old copper sheet, silver soldered together. It works like a pulse jet, filled with water. A candle flame heats this part and steam pushes the jet of water out the back. The steam condenses and more water is drawn in, creating a pulse cycle. With no moving parts, it's amazing to see it work. Anyway, these castings. The block was a little beaten up and may not have been perfectly flat. This scrap faceplate may be better. Ink is used to see where material is being removed. Layout ink is more commonly used for this, but a marker is more convenient and works. As before, just a tiny bit is left at the bottom. Pretty much gone. This time ink is left at the top and bottom. With the ink rubbed off, the parts should be flat. Nope. Recalculating. My technique may be poor, as this method works for some people. Rubbing the plate with an oil stone will show up any high spots, but it will also leave a tiny amount of grit on the surface. These parts can be lapped against the metal plate. This should be far more accurate than using abrasive paper. Light hand pressure is used to avoid flexing the parts. You can see where it has polished the part, only in the middle. This is the same for the other part. This is going to take ages. I need to mechanise the process. This brake disc has been selected from the scrapyard because it has a wide uninterrupted surface. It needs to be simply faced off. Something's going wrong here. It should be stopped, but it's slightly mesmerising. The tool shifted slightly and increased the cutting depth. It's faced off flat, but the surface finish could be better. With the carbide tool freshly sharpened, a finishing cut can be made. There, I seem quite happy with that. To protect the bed from abrasives, some old-fashioned grinding paste. Can't remember if fine or coarse was used. Probably fine. It looks like the red end. Fine would give a more accurate result. Testing it on a failed casting. It's too sticky. WD-40 will thin it. That's better. It can be spread out evenly with this casting. Then onto the carburettor. The snapping action is very gentle but accurate. Not there yet, getting better. The surface looks even. Now the parts don't rock against each other. The throttle body flange is to be machined, so it needs to be clamped down. These mounting plates for small parts are made here, so one can be borrowed from stock. Care must be taken to avoid distorting the part, as it's soft metal. The original plan was to use 2 straps to hold it down, pressing on a large area, but these lumps are in the way. So the 4 holes will be used with small screws and washers. There were no T-nuts, so these had to be quickly made. These 4 have M5 threads, and these matching screws have been sought out. Checking that it's sitting flat. The screws must be tightened bit by bit across the workpiece to reduce the risk of bending it. Ready to go? This could be mounted on a lathe faceplate, but the zinc material is best cut at speed. Rotating this at high speed on a faceplate would be dangerous. Although facing this at moderate speed on the lathe would work well enough, the face will be milled with this cutter. It's a cheap carbide tip end mill, but it's too light to work properly as an end mill, but it makes a good facing cutter. The mounting plate can be bolted to the machine table. The part was meant to line up with the machine table. The cutter speed is higher than could be safely attained on the lathe. A few passes are used to avoid overstressing the component. The surface is now flat, but the finish is rough. The zinc can be a sticky material, so a light lubricant is required, traditionally paraffin, which is flammable and smelly. Some popular water displacement spray is convenient and usually works well for aluminium and zinc. This isn't the BBC, it's WD-40. It prevents chips from sticking to the cutter and ruining the surface finish. A slow feed is used for best surface finish. There is a burr around the edges. This can be used to our advantage to mark the gasket paper. This is thin gasket paper, so the flange doesn't distort on tightening. However, the thermal insulation of the thicker gasket will be lost. The engine doesn't run that hot though, and if it is a problem, a phenolic gasket could be made. There is a trick where a hammer is used to cut the gasket paper against these sharp edges, but this zinc material is too soft and the hammer would damage it. Now the part can be deburred. Attempting to release the screws incrementally to avoid distortion. And checking the surfaces. Nice and flat, great. That's the end of this part. The next video will be about making new parts. Thanks for watching, goodbye.